I have a dream, that's all I need. I'll make it happen with some work and belief. Know what I want, so I'll take it on. I've made mistakes, but mistakes make you strong.
Hello guys, what's up? Welcome back to my YouTube channel, Math-matictv. So for today, I will introduce the integral calculus. But first, what is the integral calculus? The integral calculus is an inverse for the differential calculus. Because in differential calculus, we're just differentiating. But for now, we're going to integrate the integrals. So it means that before you proceed to integral calculus, you must first have a huge knowledge about the differential calculus, because we need the differential calculus in integrating integrals. But for now, I'm going to integrate integrals using the power formula. So what is the power formula? The power formula is the integral of x raised to n with respect to x is equal to x is to n plus 1 over the n plus 1 then plus the arbitrary constant. But there's a condition that n must not be equal to negative 1, or this exponent must not be equal to negative 1. Why? Just watch this. If we integrate x raised to negative 1 with respect to x, so following this formula, this is equal to x raised to negative 1 plus 1 over negative 1 plus 1. So I can simplify this into x raised to 0 over 0. So this is undefined and wrong. So before you use this formula, the exponent first, or the n, must not be equal to negative 1. So let's try some example. So what if we're going to integrate x plus 1 with respect to x? So this is the same in the integral of x plus 1 raised to 1 dx. So since the exponent, or n, is not equal to negative 1, so we can use this formula. And the derivative of x plus 1 dx is just dx, so we can directly apply this formula. So this is equal to x plus 1. So 1 plus 1 is equal to 2. Then 1 plus 1 is equals to 2. So then don't forget to add the arbitrary constant, which is c. So this is our final answer. Second example, so we're going to integrate square root of x with respect to x. So first, we're going to rewrite this into x raised to 1/2 then dx. So the exponent, or the n, is not equal to negative 1, and the derivative of x is just dx. So we're all set, and we can directly use the formula. So this is equal to x 1/2 plus 1 is equals to 3/2 over 3/2. So as the constant. But you can still simplify this into 2/3 times x raised to 3/2 then plus constant. Why I multiplied 2/3 here? Because the reciprocal of 3/2 is 2/3, so it will become a multiply. So this is our final answer. So let's proceed to the third example. So what if we're going to integrate 2x plus 1 raised to 2 dx. So how can we solve this? So we can apply the power formula since n is not equal to negative 1. But look the derivative of 2x plus 1. So what is the derivative of 2x plus 1? So the derivative of 2x plus 1 is equals to 2 dx. So the d over dx of 2x plus 1 is equal to 2 dx. So we need to put 2 here, and we need to multiply 1/2 here. So the 2 will be cancelled. So still the same in 2x plus 1 raised to 2 dx. Now we can integrate 2x plus 1 raised to 2 using this formula because we're all set now. So this is equal to 2x plus 1 raised to 2, then plus 1 will be 3 over 3, then plus c. But we multiply 1/2 here, so this is equal to 2 times 3 is equals to 6. Then multiply by 2x plus 1 raised to 3, then the constant. Or if you want, you can set or you can put the value of u equals to 2x plus 1. Then our du is equals to 2 dx. So to get the value of dx, dividing to both side 2 and 2 here, this will cancel, then du over 2 is equals to dx. Now we will use this variable and to integrate this, so this will be equal to integral of, since u is equals to 2x plus 1, so integral of u squared, then du, then dx is equals to du over 2, so multiply du over 2. So since 2 is a constant, we can put here outside in the integral, so this is the same in 1/2 integral of u squared du. Now we can use the power formula since the exponent is just 2 and that equal to -1, and the derivative of u is just du, so we're all set. So the answer is u 2 plus 1 is equals to 3 over 3, then the arbitrary constant. So, and there's a 1/2 here, so we should multiply this, so it's equal to 16 u cubed plus c. But u is equals to 2x plus 1, so we should substitute back the value of u. So this is still equal to 16 2x plus 1, then raised to 3 and the constant of integration. So this is our final answer. So let's proceed to our last example. 5x plus 10 raised to 5, then dx. So again, since the exponent is not equal to -1, we can use the power formula. But look at what is inside in the parentheses. The derivative of 5x plus 10 is equal to 5 dx. So we need to put 5 here, so to balance. And we need to multiply also 1/2 here, so to still balance the equation. So 5x plus 10, so if we multiply, this is a 1/5. This is 1/5 because we multiply 5 here, so we need to multiply 1/5 here, so to maintain a balance in the equations. So now we're all set. We can apply this formula directly. So this is equal now to 5x plus 10 raised to 5 plus 1 is equals to 6. Then let's divide 6. Then don't forget to multiply this 1/5. So times 1/5. So we can simplify further into 1 over 30, then multiply by 5x plus 10, then raised to 6. Then the constant of integration. So the final answer is here. So again, I will approach what I did earlier for the integral of 5x plus 10 raised to 5 dx by putting u is equals to 5x plus 10. And our du is equals to 5 dx. And if we want to get the value of dx, we will just divide both sides by 5. So this will cancel, and du over 5 is equal to dx. Now, use this variable to solve this integral. So this is equal to u raised to 5, then multiplied by du over 5. So again, since 1 over 5 is just a constant, we can put this outside in the integral. So this is equal to 1 over 5 integral of u raised to 5 du. Now we're set because n is not equal to -1, and the derivative of u is just a du. Now this is now balanced, so you can apply directly the formula. So this is equal to 1/5 times u raised to 5 plus 1 equals to 6, then divide by 6. So this again equal to 1 over 30 u raised to 6, then the constant of integration. But we must put back the value of u, so which is 5x plus 10. So this is equal to 1 over 30 5x plus 10 raised to 6, then our constant of integration. So this is our final answer. That's all for today, guys. Thank you. Please subscribe to my YouTube channel, and God bless.
I have a dream, that's all I need. I'll make it happen with some work and belief. Know what I want, so I'll take it on. I've made mistakes, but mistakes make you strong.